so we have two types of exponential functions to consider. When b is greater than 1, the function y equals b to the power of x is a continuous increasing function. So 2 to the power of x, 3 to the power of x, 5 to the power of x. So we have, as that number gets bigger, the more rapid the function increases. Okay, so we have something that looks like this. All right, and so if we were to think about limits in this graph for the purpose of curve sketching, the limit as x approaches negative infinity. So here's my negative infinity, and as I approach negative infinity, my graph is approaching my horizontal asymptote. And remember, a limit's all about what's it approaching, not really if it's going to get there. So as I approach negative infinity, my graph is going towards 0. And when I look at it as x gets infinitely big on the positive side, so what's happening to my graph? Well, it's getting infinitely large, so it's going to infinity. Now, if we think back to chapter 1, that limit itself really does not exist. Okay, but for the purpose of curve sketching, we would want to know that the graph was going to infinity. And then if we look at when b is between 0 and 1, we have a decreasing function. And the smaller the value of b, the more rapidly the function is going to decrease. So this time, if I look at as x approaches negative infinity, in fact, this time around, my graph is getting infinitely large. Again, that doesn't really exist for a limit, but for the purpose of my graph, I want to know that he's going up to infinity. And then as I look, as x gets infinitely large, I'm approaching that horizontal asymptote, so the limit is going to 0. All right, so that's just keep those graphs in mind for curve sketching purposes. It's not so straightforward for limits. There's kind of not really a this rule for this like there was in trig. Really, it's all about kind of analyzing, if I can get the word out right, what is happening as x approaches this number. So let's look at this limit. As x approaches 3, remember this little negative means from the left. So I'm just going to look at this exponent for a second, okay? Obviously, direct substitution is not going to work because it'll give me a 0 in my denominator of my fraction. So I'm really just going to analyze this, break it into little pieces. So if I look at 1 on x minus 3, and I think about x being a very small number on the left, right? So 2.99999 minus 3 is going to give me a small negative number. So this is going to be 1 over a small negative number. So what happens when you go 1 over a very small number? You get a very large number. But because we're negative, this is going to be a negative big number. Okay, so that's just kind of looking at the exponent. So now if I think about putting that exponent with my base of 2, I now have 2 to a very large negative number. Well, with my exponent rules, I could put that 1 over 2 to the positive large number. And so 2 to the power of a very large number is going to be a very, very large number. And so now I have this is 1 over a very big positive number. And 1 over a very big number is going to tend towards 0. So that brings us all the way back to the fact that our limit as x goes to 3 from the left of 2 to the power of 1 on x minus 3 is actually going to go to 0. Okay, so you really kind of just have to analyze the pieces, not as nice on some of these questions. Okay, number 2. So as x goes to infinity. So really think about this, guys. 3 times a very, very large number minus 1 is still going to be a very large number. This is going to be 7 to a very big number. Well, of course, that's just going to go to infinity. Okay, now again, the limit itself does not exist. We can't say a limit is infinity. This is really about analyzing for curve sketching. Okay, what's number 3 say? We have 6 to the power of 1 on x, and we're looking at the limit as x goes to 0 from the right. So that just tells me I have a very small number. Okay, 1 over a very small positive number because I'm coming from the right, right? So 0.0001. 1 over a very small number is going to give me a very big positive number. So this is the limit as x goes to 0 from the right of 6 to the power of a very big positive number. So what's going to happen is this is going to go to infinity. Okay, this limit will go to infinity. Okay, last one. Could we use direct substitution on this one? So sine of 0, does it work? Sure does. What is sine of 0? Sine of 0 radians is 0. If you think about your unit circle, throw some trig into our exponential unit. So we have 3 to the power of 0. What's going to happen here? So we've got the limit as x goes to 0 from the left of 3 to the power of 0, which is just going to be 1. So there we go. There was one example where direct substitution worked. Again, these limits are not super fun. They're just really more about we're going to have to analyze what's happening so we know something about the curve sketch down the road. All right, that's the end of 8.1. I will see you back for 8.2 for those of you who want to see about the derivatives.